Hello friends, welcome to my channel. My name is Harshal. So in previous video means in part 1 we discussed the electricity. Part 1 means we discussed what we discussed, electric charge we discussed, electric current we discussed. Now we are going to discuss potential difference, resistance and resistivity. Can we start? Yes, come with me. So let's start from potential difference. What is potential difference? We completed the electric charge and the electric current. The third point is the potential difference. So potential, we in previous standard, previous grade 5th, 6th, 7th, we know what is potential. But what is potential difference and in current? What is it? We are going to explain it. Since tank A has higher water level, it is not an electricity. I am giving an example of two tanks which are filled with water. By this example, we can understand the potential difference. Since tank A has higher water level, so water will flow from tank A to tank B. Means here is the water level is high and here is water level low. So then all the water there it flows from tank 1 to tank B. But what is the difference? Yeah, the difference is here it water level is high and in tank B the water level is low. So this difference is known as potential. Means in this difference the potential is low in tank B and in tank A it is high. So this distance, this difference is known as potential difference. That is the concept of potential difference. So let's see in electric. Yeah, here I denoted this distance is known as potential difference. So what is this? Here also in a wire or in a conductor, all the electrons mean negative are there, and in one another wire there are some low negative like this. So where are high negative, they all flow through the battery through the wire into the low negative. That's why this is known as potential difference, and potential difference is very important concept in the electricity chapter. So in wire we can see, yes, here is a high level and here is low level, but this is wire that makes low to high, means it makes high level. मतलब I am going to tell this in Hindi. Means electric potential difference between 2 points in an electric current. Carrying current can be defined as amount of work done to move a unit charge from one point to another. Yeah, this is compared with work done with W, and when the work done is ratioed by or divided by charge, we can get the potential difference. Means V stands for potential difference voltage and work done W upon Q. Q is the charge, SI unit of charge. Yes, it is. Means what is the meaning of potential difference is that means there is 2 points in electric current, but they carrying different current as defined as amount of work. So it can do that it from one point to another point it carry the current. Means from higher tank we seen the higher a tank A and tank B. Means from tank A to tank B it is moving the charge, it is moving the current through a time is known as electrical potential difference. I hope you will understood. So this is the formula of potential difference. V stands for potential difference voltage and W stands for work done. Okay, let's move ahead. It is also potential difference here. We can also calculate this by this also, means 1 joule upon 1 coulomb is equal to 1 volt. By this we also find the voltage, means potential difference. So define the 1 volt. It comes in exam. Volt, 1 joule is done 1 minute. 1 joule is done carrying 1 coulomb charge from potential difference is called 1 volt. Yeah, simple meaning it is that a 1 joule work is done in carrying on 1 coulomb charge, that potential difference is known as 1 volt. Measuring distance of potential difference is voltmeter, stands for this in circuit diagram. Yes, let's move ahead. Ha. It is voltmeter is connected in parallel. Means if there is a current or if there is a resistance, then voltmeter is parallel to it. Voltmeter is parallel to current. Voltmeter is parallel to this wire. It is not connected in series like ammeter. It is connected in parallel. It is the device you can see. Let's move ahead. Now current depends upon, we know electric potential difference. Then what is current? Current depends upon what? That we can see. Current depends upon the potential what potential difference here means in tank A and tank B. This difference is also connected with current, means here is current is high and here is low, but due to potential difference all current is moving here high, means high to low. So this is that we can say that current depends on the potential difference. This is cell and this is our wire that contains all electrons, and when we put it cell, then it moves faster negative to positive, but in actual connection we see positive to negative. I told in session 1 part 1, please see session 1. If you didn't saw the part 1, you can't understand this part 2. Let's move ahead. Potential difference, yes, it is also a concept of potential difference. That is, when potential difference is high, the current flow also high, and when potential difference is low, the current flow also low. That's why we can say that potential difference is, yes, you are right, potential difference is directly proportional to the current. Yes, means when it is high, when it is the potential difference is higher is high, then it will move faster, and when it is low, then it moves slower. So that we can understand that potential difference is directly proportional to the current, and current is depends upon the potential difference. Current also depend upon the resistance, but we are going to teach later, going to explain, learn that resistance later. So now on this moment we only remember that current is depend on potential difference. I hope you will understand. Now current depends on, it's over. Yes, this is known as Ohm's law. Simple, means current is directly proportional to the potential difference, means also vice versa, potential difference is directly proportional to current. This law, this concept is known as Ohm's law. And by this we can also find the resistance. V is equal to R into I. This is the formula. R stands for resistance. We will explain this in ahead. So let's move ahead. Current depends on, yes, it is resistance and current. So this is my favorite diagram. What is this? We can understand that this red ant stands for move. Red ant stands for R, and this stands for I, and this light green stands for V. Means we can understand what we understood, that all current is depend on resistance also and potential difference also. Potential difference, if it is high, then current is also high, but in resistance it is opposed to the current. Means if resistance is high, means resist is high, then current is low, and if resistance is low, then current will high. So by this we can understand that resistance is inversely proportional to the current, and potential difference is directly proportional to the current. I do your diagram. Resistance is inversely proportional to the current, and here potential difference is directly proportional to current. That symbol. Yes. Let's move on. This symbol get fixed in this your mind. Now what is resistance? We are going to teach resistance. It is very hard and important topic. It is also one of the important topic in electricity. So here we can see it is a wire, metal wire, conductor wire. Here we can see protons and nucleus are in, and the electrons are moving like this. Means there are very small particles. Electrons are very small particles and lie. Then what we can understood that when current is passed through, means here the electrons are passing through, they collide to protons, they collide to nucleus, they collide to other atoms. This collision is called as resistance. Why does it called as resistance? Because the collision happens the decrease the speed of electrons. Yes, speed of electrons, decrease the current, decrease the speed of electrons, decrease the charge. These collisions means here your zigzag, then after it bounces back by the protons atoms in the wire in the atoms. That we can say that this collision, this resistance known as resistance. Yes, in this wire the other particles includes protons, nucleus and the atoms. These collides the electrons. Means in the electrons they are such like a which you can say that means in a road, in a traffic jam, we can say it is a traffic. Here is a car, we can say it is an electron, and here are also electrons. But in there are show trees, there are other vehicles. These all are collisions, means resistance particles, and these cars are electrons. This is an example of resistance. Let's move ahead. The resistance is what? It is the property of conductor to resist the flow of charges through it. Yeah, it is the property, means collision, the property to resist the current, to resist the flow of charges, to resist the flow of electrons. The SI unit of resistance is ohm, stands for this ohm. This is an it called as omega in Greek, but we called it ohm. Yes, let's move ahead. Now let's move. What is this? Yes, this is also an example. This is all, it is an electron, and this is all atoms and protons that they collide the electrons, means they this is the property to resist the flow of charges. It is the flow of charges. It is known as resistance. Let's move ahead. Resistance. It is an device used in circuit. The circuit diagram of resistance, symbol of resistance in circuit diagram is this. And there is also a variable resistance known as rheostat. What is known as rheostat? It is, the word is very disgusting, but it is also an important. It is known as variable resistance. Means we can change the resistance. We can change the resistance in the rheostat. But in the simple resistance, we can't change. And the symbol of rheostat is like this arrow, or like this. We can say like this also. This you can say. Ohm meter means the device used to measure the electrical resistance is ohm meter. It is like a ammeter and voltmeter. So let's move ahead. Ohm. SI unit of resistance, we see. Unit. What is the unit of resistant? Ohm meter. Yes, the unit of resistivity. We know the resistance, what is this? But resistivity means that in a material, what it's a separate, means in silver its resistivity is different, in copper, in iron, in alloys, they all have the different resistance, that is called resistivity. And the SI unit of resistivity is ohm meter. Ohm meter written car, but it is an resistance. Yes, it is denoted like resistance this, and resistivity is denoted like ohm meter. And the formula of resistance is V upon ampere. Means 1 ohm, means 1 resistance, 1 ohm is equal to potential difference upon the ampere. Ampere stands for current, means potential difference upon ampere. We can say also volt upon ampere. So let's move ahead. Now the resistance of conductor depends on, means how the resistance increases or decreases, what it depends upon on. So it is like a traffic, but first we can see like this, means if the length is high, if the wire length is high, wire length is big, the resistance also big. Yes, if the wire length is small, the resistance level also small, in also in traffic also. Means it is on traffic road, if it is length is big, then traffic is more. Traffic stands for resistance, traffic is more. But it is a small road, then traffic is less. Like this only the resistance also depends. So by this we can say resistance is directly proportional to length of conductor. Yes. Now the other is, if the area of conductor is more, the resistance of the conductor is low. Means if the width, if the size of road is more, then all the vehicles move easily. So the resistance, means the collision traffic will decrease. So by this we can say that resistance is inversely proportional to the area of conductor. Understood? If you understood, now get subscribe and like to the my channel. It doesn't need any money. So now what is rho? Yeah, rho stands for resistivity. I told you. Rho stands for resistivity and its SI unit is ohm meter. The SI unit of resistance is ohm, but the SI unit of resistivity is ohm meter. What is the definition of resistivity? Ability of material to oppose the flow of current. I told, means the ability of material, all material have different ability of resistivity. So this stands for rho. 1 minute, this stands for rho, means like this, bending P, this stands for RHO. Then if we find the resistance, if we also find the resistance, but it is not possible, we need a constant term, then we term the rho, means rho L upon A, means resistance is equal to rho length of the area upon ampere. Yeah, it is very easy. Now let's move ahead. A stands for area. This is also an example. We see the length. Now it is the area of resistance. Means if we find the R is equal to, I told rho. R is equal to rho. Rho stands for resistivity. L upon A. L stands for length of the conductor. A stands for area of conductor. So when we find the length and area, we use the constant term known as rho. Let's move ahead. Resistivity. The symbol of resistivity is L, means rho. And the SI unit of resistivity, ohm meter. Ohm meter stands for ohm meter. Yes, easy. So, now the last session, means last part of this video. Chapter didn't end, but the video is going to end. So means all materials have all different resistivity. Means conductors have low resistivity, then insulators have high resistivity, so they can insulate, means they cannot flow the current, so they, because they have resistivity is very high, and conductors have low resistivity. And why we make alloys? Due to means it for avoiding the metal to burn. If we use copper or nickel or tungsten, it is a metal and very conductivity is very high than the resistivity. So we make the alloys for increase the resistivity. Means 49, 44, 100, their resistivity is high when we mix all these metals. This all the here. This chart present in our NCERT 10th standard textbook. You can read. It is for only solving the resistivity problems, solving the resistivity numericals. For more videos, like and subscribe to the channel Harshal Kore. Bye bye.